Bismillahirrahmanirrahim. Today I come up with exercise number 8.5, and the exercise is related with the heights and distances for class 10. The first very question of the exercise is, if a tree breaks, let's consider this as the tree, and let's consider this as the ground surface. So we will write it as ground surface, and this is the height of the tree. Rather, we will write height of tree. So once a storm comes, let's consider this the direction of the storm, and it breaks this tree here. In this breaking part, it touches the ground, makes an angle of elevation, and that is 30 degree. So if this is a ground surface, if it is AB, and the height of the tree, if it is BC, then it means here it breaks at point D, and this is the breaking part of the tree. So it means if this DC, if it is x centimeter of height, this AD is also of x centimeter of height, because this is the same part which breaks due to storm. And let's consider this as the y centimeter of length. And what we had to find? We had to find the height of the tree. So it means we are having tree right now in this direction, and here we are given the ground surface, and this ground surface is of 8 centimeter, and this is the one part of the tree, and this one part I denote with y centimeter, and this is the broken part of the tree that I denote with x centimeter, and then we are having angle of elevation that is 30. So let's consider this as A, B, and D. And the question is, a tree breaks due to storm, and the broken part bends so that the top of the tree, this is C is the top of the tree, this top, it touches top of the tree, it touches the ground, making an angle of elevation that is 30 degree with the ground. So this is the angle of elevation here, and this angle of elevation, it is 30 degree. The distance from the foot of the tree, so here it is the foot of the tree, to the point where the top touches the ground. So this is the point where the top touches the ground is of 8 centimeters. So it is 8 centimeter of length. Then what we have to find, we will write 8 meter, rather it is in meters, 8 meters. So in this direction I will also write meters now. We have to find this BC, that means the broken part of the tree. We will write it as let this DC, or we will say BD, this part of the tree, it is of y meter, and then DC, it is of x meter, this DC is equal to AD, and both they are of x meter of length. Now it is also given that the ground where it touches where the top of the tree touches the ground from the foot of the tree is of 8 centimeters. So we will write AB, and AB is the ground surface and is of 8 meter. So in this manner we get a right angle triangle here. This is the right angle triangle now, because the tree, it always acts at 90 degree with the ground surface wherever there is no seismic activities. That is why it is 90 degree here. So I will take in right angle triangle A, B, D, right angle at B. Here this part is given, and we need this part and this part. Firstly, we will calculate this BD. So in this manner we are having base is given, and then we are having the perpendicular. So perpendicular and base means the tan, so we will take as tan of 30 degree, or we will also calculate here the chord. So it is tan of 30 degree, and this tan of 30 degree is side opposite, that is y meter, and side adjacent, that is 8. But in trigonometric table, tan of 30 degree is equal to 1 by under root 3. So we will use its value, that is 1 by under root 3 is equal to y by 8. If we will calculate it further, we will get, or we will keep it as it is. Consider it as first here. Now in this manner we get the BD. Now we will calculate this part. Here the adjacent part is given and the hypotenuse is given. So once again in right angle triangle, the same triangle in right angle triangle ABD, right angle at B, here it is right angle. So we will calculate here cos of 30 degree, because cos is equal to the side adjacent, that is 8 meter, upon hypotenuse, that is x. But cos of 30 degree in trigonometric table, cos of 30 is equal to under root 3 by 2. So we will use its value, that is under root 3 by 2. So we will write as under root 3 by 2 is equal to 8 by x. Or if we want to calculate the value of x only, so we will write it as x, or we will first of all taking reciprocals. So by taking the reciprocals, we will write 2 by under root 3 is equal to x by 8. So in this manner, we will be able now to calculate the value of x as it is to 8. It is equal to 16 to 8 or 16 by under root 3 meters. If we will see your first one, that was equal to this 1 by 3. If you want to calculate here the value of y, you will get it easily. Y is equal to 8 ones or 8 by under root 3. So in this manner we calculate both the values of x as well as the value of y, because x and y together makes the height of the tree. So if we want to calculate now the height of the tree, we will write it as height of tree, that is equal to x plus y meters, and x we will use its value, that is 6 by under root 3, plus y, it is having value 8 by under root 3. So once in denominator we are having the same value, we will write it as 6 plus 8 by under root 3. So 6 and 8 makes 24 by under root 3. 24 by under root 3. But dear students, we are having root in denominator, so we will go for rationalization. We will rationalize it by under root 3 like this. So under root 3 by under root 3. So that will give us 24 under root 3 by 3 only, because under root 3 into under root 3 means under root 3 square, and root cancel, we get 3. And thereafter 3 8s are 24. So we will write 8 into under root 3 meters. So in this manner, we calculate the height of the tree, and that is 8 under root 3. Once again, let's have a recapitulation. The question was like this: the height of the, this was the tree B and C. It was the tree, and once the storm comes in this direction at point D, the tree breaks, and the upper part of the tree, that is the broken part now, it touches the ground and makes an angle of 30 degree with the ground surface. So this is the ground surface and this is the broken part. It means this DC and DA, they are of equal length, because this AD, it is the part of the tree. And then BD, I consider it with Y centimeter, and this, and DC, I consider it is equal to the X centimeter. And then in solution, I write these. What is AB? AB, it was given and it was equal to the 8 centimeter. And then this BD, that I put and make it, and make equal to the variable that was X, and that was Y. And then DC and AD, they are of equal length, and that is X centimeter. Then I take this right angle triangle. Why it was right angle triangle? Because here this, the heights and distance, it is related with the space sinus. Once we will put the tower, or once we will put the building with the ground surface, always we keep in mind the 90-degree angle in order to erect the building or the tower. And same is the case with the tree, but sometimes you will get the tilted tree somewhere. That is because of the seismic activity of the area. And then I take this, the right angle triangle here, this ABD, and it was right angle B, and the ground surface was given, and our focus was on this part, the y meter part, that is the height of the tree BD. So it means here base was given, and the altitude, rather we can say the opposite part and the adjacent part was given. Opposite and adjacent, wherever they two are given, we will go for the tan and the chord, because tan is equal to the opposite by adjacent, or chord is equal to adjacent by opposite. In this manner we get the value of y, and thereafter once we calculate the value of y, then we focus on the another part, that is the hypotenuse, rather we can say. And once we focus on that very part, we get the value of this hypotenuse, that was the upper part of the tree. And then I add this X as well as the Y, because that is the height of the tree, and once I add them, we get the value. Hope you understand it very well. Thank you.